Hello, in this lecture we will find the value of 2 times AP. We'll find the value of 2 times AP, or the size of 2 times AP. Okay, actually we have in the picture triangle ABC. Side AB of the triangle is 90 units. Side AC of this triangle is 70 units, and side CB of triangle ABC equals to 50 units. And we also have a circle, and the center of this circle is point P, and actually we have 2 tangents to this circle. The first tangent to the circle is side AC of the triangle, is tangent to the circle at point, we'll call that point O. Again, side AC of the triangle is tangent to the circle at point O, or the touching point between side AC and the circle is point O. Okay? Again, side AC is tangent to the circle at point O, and also side CB of the triangle is tangent to the circle at point, we will call that point point E. Again, side CB or BC is the same. Side BC of the triangle is tangent to the circle at point O, this point E. Again, side BC of the triangle is tangent to the circle at point E. This point E, and actually the touching point between side CB of the triangle and the circle is at point E, this point. Okay, and the touching point of side AC with the circle is point O, or AC is tangent to the circle at point O, and the CB is tangent to the circle at point E. Okay, in the next step we will connect points O and P together by a straight line. Actually, OP is the radius of the circle. I will call it R, abbreviation of radius, because it starts from point P, the center of the circle, and ends at point O on the circle. So PO or OP is the radius of the circle, because this is the definition of radius of any circle. When you have a straight line that starts from the center of the circle, that is to say from point P, and ends at any point on the circle, then it is considered as a radius of the circle. So PO is the radius of the circle. Okay, and in the same way we will connect points P and E together by a straight line. And for the same reason, PE is also the radius of the circle. I will call it as R. It starts from the center. The line OP starts from the center of the circle and ends and point E on the circle. For this reason, point P9, the straight line PE, is the radius of this circle. Okay. We have a rule that in any circle a radius and a tangent to that radius are perpendicular to each other. Okay, so PO is the radius of this circle and AC is a tangent to this circle. AC is tangent to this circle. Side AC of the triangle is tangent to this circle at point O. So in any circle, the radius and the tangent to that radius are perpendicular to each other. For that reason, OP or PO is perpendicular to side AC of the triangle. That is to say, angle POA is equal to 90 degrees, and also angle POC is equal to 90 degrees, because PO is perpendicular to AC. For that reason, this angle is 90 degrees and this angle is also 90 degrees. Again, I repeat, in any circle, the radius and the tangent to that radius are perpendicular to each other. Okay, so I will write it down. Rule number 1. In any circle, a radius and actually the tangent to that radius are perpendicular to each other. Read it again. In any circle, a radius and the tangent to that radius are perpendicular to each other. Okay, in this circle we have radius PO and tangent AC to the circle, so PO, that is the radius of the circle, is tangent, is perpendicular to side AC of the triangle, and the angle POA is 90 degrees, and also angle POC is also 90 degrees. Okay, and for the same reason, because of the fact that we have PE, line PE is the radius of the circle, PE is the radius of the circle, and CB is tangent to the circle at point E. And according to our rule, a radius and the tangent to this radius are perpendicular to each other. That is to say, angle PEC equals to 90 degrees, and angle PEB also equals to 90 degrees. Okay, it is correct for any circle. When you have radius and you have a tangent to that radius, then they are perpendicular to each other. Okay? Again, in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay? So we have here two radiuses, and we actually created the triangle AOP is a right triangle because angle POA equals to 90 degrees. So triangle AOP is a right triangle, and also triangle BEP is also a right triangle because angle PEB equals to 90 degrees. So we actually created two right triangles. This is a right triangle, and also this is a right triangle. Okay, so in the next step we will draw a perpendicular from point C to side AB of the triangle. Okay, so we will draw a perpendicular from point C to side AB of the triangle, and we will call to the touching point between the perpendicular to side AB of the triangle M capital. Again, the touching point between the perpendicular that starts from point C, between the perpendicular to side AB that starts from point C, the touching point between the perpendicular and side AB of the triangle is point M. Okay, so according to the definition of perpendicular, we can say that angle CMB equals to 90 degrees because this is the definition of perpendicular. Okay, CM is perpendicular to AB. For that reason, angle CMB equals to 90 degrees. And also, we created here right triangle. CMB is right triangle because angle CMB equals to 90 degrees. And also, angle CMA will be 90 degrees because of the fact that CM is perpendicular to AB. So from both sides of point M, we have 90 degrees. This angle CMB is 90 degrees, and also angle CMA is 90 degrees. So actually we created here two right triangles. The first right triangle is CMB, and because the angle CMB is 90 degrees, for that reason triangle CMB is right triangle. And the second right triangle is the triangle ACM. ACM is right triangle because angle AMC equals to 90 degrees. Okay, so we created here two right triangles. So in total we have here four right triangles. This is the first one, this is the second one, this is the third one, and this is the fourth. Okay, so or I can say that APO is right triangle, that is the first one, and also ACM is right triangle, that is the second one, and BEP is right triangle, this is the third one, and BCM is the fourth one. BCM is also right triangle, and this is the fourth right triangle that we created in the drawing. Okay, so now we will define angle CAB or CAP as alpha. So angle CAB or BAC or PAC equals to alpha, and also we will define angle CBA as beta. Okay, angle CBA equals to beta, or also angle CBP equals to beta, or we can say that angle PBC equals to beta, or angle ABC equals to beta. Okay, and we will also define AP as x. Okay, AP equals to x. So PB will be equal to AB minus AP. That is to say, AB is 90 minus AP, that is x. So PB equals to 90 minus x, because this AB is 90 and AP is x. So AB minus AP equals to PB, or 90 units minus x equals to 90 minus x, that is actually PB. Okay, so in the next step we'll focus on two right triangles in this side of the drawing. We'll focus on the right triangle AOP, and also we'll focus on the right triangle ACM. Okay, triangle ACM. So both of those triangles are right triangles. So I've already explained. Triangle AOP is right triangle. Here is 90 degrees. And triangle ACM is 90 degrees because angle CMA equals to 90 degrees. Okay. Now, first of all, we focus on triangle, the right triangle AOP, and in this right triangle AOP, sinus alpha equals to the angle that is in front of angle alpha, that is to say OP, divided by the hypotenuse of the right triangle AOP, and the hypotenuse of triangle AOP is AP. Because side AO and side OP of the triangle AOP are perpendicular to each other, so side AP is the hypotenuse of the right triangle AOP. So sinus alpha equals to the angle that is in front of angle alpha, that is to say OP, divided by the AP, that is the hypotenuse of the right triangle AOP. Okay, so in general, sinus alpha equals to the angle that is in front of alpha divided by the hypotenuse of the triangle. Okay, so the angle that is the side that is in front of angle alpha is side OP of the triangle, and the hypotenuse of the right triangle AOP is actually AP. Okay, so sinus alpha in triangle AOP equals to OP over AP. Okay, then we will focus on the right triangle ACM. In triangle ACM, sinus alpha equals also to the side that is in front of angle alpha, that is to say CM. CM is in front of angle alpha, over the hypotenuse of triangle ACM, and the hypotenuse of triangle ACM is actually AC, because side CM is perpendicular to side AM. Here we have 90 degrees, so AC is the hypotenuse of the right triangle ACM. Okay, so it is CM over AC. AC, that is the hypotenuse of the right triangle ACM. Okay, so we have in total the equality that sinus alpha equals to OP over AP, that equals to CM over AC. Now we will write again this equality, and in this way we will create the first equation. Okay, so the first equation will be OP over AP equals to CM over AC. Okay, here I copied this equality to here, and this is actually our first equation. AOP over AP equals to CM over AC. Okay, but we defined AP as X, so we can write down that AP equals to X, and as I've already told you, PO or OP equals to the radius of the circle, so OP actually equals to R, the radius of the circle. OP equals to R, and the side AC of the triangle ABC is given to us. We know that the size of side AC equals to 70 units. So we can write that AC equals to 70 units. AC equals to 70. I will not add the word units because actually it is correct for all the other variables, AP and OP, all are units. Okay. So we know that AP equals to X according to our definition. OP equals to the radius of the circle, that is R, because it is from the center of the circle, starts from the center of the circle and ends and point O on the circle, so it defines as the radius of the circle. And AC, side AC of the triangle ABC equals to 70 units. Okay, so now we can substitute OP by R, AP by X, and AC by 70. Okay, so I will do it now. So in the first equation, instead of OP, I will write R because OP equals to R. Instead of AP, I will write X. I will substitute AP by X because AP equals to X. Or equals to CM. We will leave CM as it is. Over AC. AC is equal to 70 units. It is given us in the question. So I will substitute AC by 70. Okay. So equation 1 is R over X equals to CM over 70. OP equals to R, AP equals to X, CM, we left CM as it is, and AC equals to 70. Okay, so in the next step we will multiply equation 1 by X. Actually we defined AP equals to X, AP as X, so X is a positive number, it can never be 0, so it is allowable to multiply both sides of equation 1 by X. Okay, so we multiply equation 1 by X, we'll get that So we multiply both sides of the equation by x. R divided by x times x equals to R. Cm times 6 over 70 equals to Cm times 6 over 70. Okay, in the next step we will divide both sides of the equation by Cm. Cm is perpendicular to side AB of the triangle. So it is a positive number, it can never be zero, so it is allowable to multiply both sides of the equation by Cm. Okay? I made a mistake. We will divide both sides of the equation by Cm. Okay? Again, I explained that Cm is a positive number. It can never be zero, so it is allowable to divide both sides of the equation by Cm. R divided by Cm equals to R over Cm, and Cm over 70 times x divided by x, or x divided by x equals to 1. Okay, so x is cancelled, so we left with I made a mistake. R divided by Cm equals to R over Cm, and Cm divided by Cm equals to 1. So Cm is cancelled from this expression, and we left with x over 70. Okay? So actually we have the first equation, that R over Cm equals to x over 70. Okay, this is our first equation. Then now we will move to the other side of the triangle, and we'll focus on the right triangle EPB. Triangle EPB, that is a right triangle, and also we will focus on triangle CBM, that is also a right triangle. Okay, so first of all we will focus on triangle EPB, the right triangle EPB. And in this triangle, sinus beta equals to the side that is in front of angle beta, that is to say PE. Again, in this triangle, this right triangle, the side that is in front of angle beta is PE. Okay, and we divide it by the hypotenuse of this triangle. As you can see, in triangle PEB or EPB, side PE is perpendicular to side EB. So the hypotenuse in this triangle, in this right triangle, is PB. So it is PE over PB. The sinus beta is the ratio between the side that is in front of angle beta divided by the hypotenuse of the triangle, that is PB. Okay, the side that is in front of angle beta is PB, and the hypotenuse of the right triangle PEB is PB, so it is PE over PB. Okay, sinus beta in triangle EPB equals to the ratio between the side that is in front of angle beta, that is to say PE, divided by the hypotenuse of triangle PEB, that is PB. The hypotenuse of triangle, the right triangle PB is PB. Okay? And then in the same way, we will, as we did in sinus alpha, now we'll do with sinus beta. We'll focus on the right triangle CMB. The right triangle CMB. Sinus beta in the right triangle CMB is the ratio between the side that is in front of angle beta, that is to say CM. Side CM of the triangle CMB is in front of angle beta, so it is CM divided by the hypotenuse of the right triangle CMB. As you can see from the picture, CM is perpendicular to MB. So the hypotenuse of triangle CMB is CB. Okay? So in triangle, the right triangle CMB, sinus beta equals to the side that is in front of angle beta, that is to say CM, over the hypotenuse of the right triangle CMB, that is CB. Okay, so it is CM over CB. Okay, so in total we got that sinus beta equals to PE over PB, that equals to CM over CB. Now I will write down again this equality, and in this way we will create the second equation. Okay, so the second equation will be PE over PB equals to CM over CB. Okay, so I copied this equality to here, and this will be the second equation. And in the same way as we did with sinus alpha, we will do with sinus beta, in the sense that we know that PE equals to R. PE is the radius of the circle. I write it down. PE equals to R. PB equals to 90 minus 6, so AB minus AP. That is to say, AB is 90 units minus AP, that is X, or 90 minus X. So PB equals to 90 minus X. And CB, side CB of triangle ABC, is given to us in the question. Side CB of triangle ABC, according to the question, equals to 50 units. So CB equals to 50 units. Again, PE equals to R, the radius of the circle. PB equals to 90 minus 6, that is to say AB, that is 90 units minus AP, that is X, so PB equals to 90 minus 6, and CB is given us in the question, that we know that CB equals to 50 units. Okay, so now we'll do in the same way that we did in sinus alpha. In the first equation, we will substitute PE by R because PE equals to R. We will substitute PB by 90 minus 6 because PB equals to 90 minus 6. And we will substitute CB by 50 because CB equals to 50. Okay, so we'll do it now. So instead of PE, we'll write R, because PE equals to R. Instead of PP, we'll write 90 minus 6. Equals to CM, we leave CM as it is, over CB. CB equals to 50, so we'll substitute CB by 50. Okay, again, we substituted PE by R, PB by 90 minus 6. We left CM as it is, and we substituted CB by 50. Okay, so in the next step, we will multiply both sides of the equation by 50. We will get that so we multiply both sides of the equation here by 50. CM times 50 divided by 50 equals to CM, and R over 90 minus 6 times 50 equals to 50R divided by 90 minus 6, so 50R over 90 minus 6. So here Okay, now we will divide both sides of the equation by Cm. It is allowable because Cm is perpendicular to side AB of the triangle. It is a positive number, it can never be zero, so it is allowable to multiply both sides, to divide both sides of the equation by Cm. So we divided both sides of the equation by Cm. Cm divided by Cm equals to 1, and 50R over 90 minus 6 divided by Cm equals to 50R over Cm times 90 minus 6. Now we will multiply both sides of the equation by 90 minus 6. It is allowable because PP equals to 90 minus 6, and it can never be 0, so it is allowable to multiply both sides of the equation by 90 minus 6. So we multiply both sides of the equation by 90 minus 6. 1 times 90 minus 6 equals to 90 minus 6. And okay. And 90 minus 6 divided by 90 minus 6 equals to 1, so we, from this equation, we have left only with 50R over Cm, because 90 minus 6 divided by 90 minus 6 is 1, so it is cancelled from the expression, and we left only with 50R over Cm. Okay, because Cm over 90 minus 6 over 90 minus 6 equals to 1. Okay, here we divide both sides of the equation by 50. So we got R over Cm, or 50 divided by 50 equals to 1, so 50 is cancelled from this expression, we left only with R over Cm, and 90 minus 6 divided by 50 equals to 90 minus 6 over 50. So we have here the second equation, R over Cm. So in total we actually have two equations for the expression R over Cm. In the first equation, we got that R over Cm equals to 90 minus 6 over 50, and from our first equation we got that R over Cm equals to x over 70, so I write it down. R over Cm equals to x over 70. So actually we have R over Cm in the second equation, we have also R over Cm in the first equation. So we will create the third equation that states that R over Cm equals to R over Cm. Okay, this is the third equation. R over Cm equals to R over Cm. And in the next step, we'll substitute R over Cm by the second equation, by the value of R over Cm in the second equation, and we will put the expression here, and in this side of the equation we will substitute R over Cm by the first equation, or by the value of R over Cm from the first equation. Okay? So here we substituted R over Cm by the value of R over Cm from the second equation, that is to say R over Cm equals to 90 minus 6 over 50, so we wrote here 90 minus 6 over 50, and we also substituted in this side of the equation R over Cm, the value of R over Cm from the first equation, and the value of R over Cm from the first equation is x over 70. So we put the value of R over Cm from the first equation here. Okay, so here we can multiply the first equation, we can multiply both sides of the equation by 50. Okay. So we multiply the opposite of the equation by 50. So x over 70 times 50 equals to x times 50 over 70, and 90 minus 6 divided by 50 times 50 equals to 90 minus 6. So here we'll multiply both sides of the equation by 70. Okay, here we multiply both sides of the equation by 70. So x times 50 over 70, or 50x divided by 70 times 70 equals to 50x. And 90 minus 6 times 70 equals to 90 minus 6. 90 minus 6 times 70 equals to 70, 90 minus 6. Now we'll divide both sides of the equation by 10. So 90 minus 6 times 70 divided by 10 equals to 7, or you can say the 70 divided by 10 equals to 7, and 50x divided by 10 equals to, I made a mistake, equals to 5x again. 50x divided by 10 equals to 5x. Okay, now we'll open the brackets on this side of the equation. We'll get that so 90 times 7 equals to 630, and minus 6 times 7 equals to minus 7x. Here we have 5x. Here we will add 7x to both sides of the equation. So 630 minus 7x plus 7x equals to 630, and 5x plus 7x equals to 12x. Now we will divide both sides of the equation by 6. So 630 divided by 6 equals to 105, and 12x divided by 6 equals to 2x. So we got that 105 equals to 2x. This is for one side, but from the other side we also know, according to our definition, that AP equals 2x. Okay? So we can add a fourth equation that states that according to our definition, AP equals 2x. Okay? According to our definition, AP equals 2x, so 2 times AP will be equal to 2 times x. Okay? If AP equals to x, 2 times AP equals to 2x. Now, we know that 2x equals to 2 times AP, and also 2x equals to 105. So we can create the fifth equation that combines equation 3 and 4 together. So the fifth equation will be two x equals, according to the third equation, 2x equals to 105. 105 units, okay? So we will write in the fifth equation to 2x equals to 105. Okay? And according to the fourth equation, 2x equals to 2 times AP. So we will add in the fifth equation that 2x also equals to 2 times AP. Okay, I'll explain it again. From one side, according to the third equation, 2x equals to 105, yes? So 2x equals to 105, but according to the fourth equation, 2x also equals to 2 times AP. So we can add here that 2x equals to 2 times AP. So we can derive from the fifth equation that 2x that 2 times AP equals to 105 units. Okay? So this is the final answer to the question, that 2 times AP equals to 105 units. Okay, 2 times AP equals to 105 units. Okay, 2 times AP equals to 105 units. So the answer to the question, find 2 times AP, the answer is that the size of 2 times AP is 105 units, so the value of 2 times AP equals to 105 units. Okay, so now I will summarize the lecture. Actually, we wanted to find the value of 2 times AP. We have triangle ABC with side AB that equals to 90 units, side AC equals to 70 units, side CB equals to 50 units, and also we have a circle. The center of the circle is in point P, it's point P, and point P is situated on side AB of triangle ABC, and also according to the question, side AC of the triangle is tangent to the circle at point O, and side CB of the triangle is tangent to the circle at point E. So we connected points O and P together by a straight line, so and this is the OP is the radius of the circle. We connected points P and E together, and P is the radius of the circle. We have a rule that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. For that reason, PO, that is the radius of the circle, is perpendicular to side AC of the triangle. For that reason, angle POA equals to 90 degrees and angle POC also equals to 90 degrees. Okay, and for the same reason, according to the rule that I mentioned, radius PE, that is the radius, is perpendicular to the tangent CB to the circle. That is to say, angle PEC equals to 90 degrees and also angle PEB equals to 90 degrees. Okay, according to the rule that in any circle, a radius and the tangent to that radius are perpendicular to each other. I'll show you again the rule. If we have radius, we call it R, and we have a tangent to that radius, we'll call it T, then the radius and the tangent are perpendicular to each other. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Again, in any circle, the radius and the tangent to the radius are perpendicular to each other. Okay, so tangent to the radius is, of course, a tangent to the circle. Okay, so in any circle, a radius and the tangent to that radius are perpendicular to each other. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay, so according to the rule that I mentioned, this angle is 90 degrees and also this angle is 90 degrees, this angle is 90 degrees, and this angle is also 90 degrees. So, and we actually drew perpendicular to side AB of triangle ABC. So CM is perpendicular to AB. This is to say CMB is 90 degrees and also CMA is 90 degrees. So, and we defined angle BAC as alpha and angle ABC as beta, and then we actually focused on two right triangles, triangle AOP and triangle ACM. In the right triangle AOP, sinus alpha equals to OP over AP. Okay, and in triangle ACM, sinus alpha equals to CM over AC. Or in total, when we relate to these two right triangles, sinus alpha equals to OP over AP, that equals to CM over AC. But we know that OP is the radius of the circle, so OP equals to R, AP equals to X according to our definition, and AC equals to 70 units. So we can put all the data in the first equation that we created. We created from this equality the first equation, and we put the data that I mentioned in the equation. So we got that R over X equals to CM over 70, and from our first equation we got that R over CM equals to X over 70. Okay, and then we did the same thing at this side of the triangle for sinus beta. We focused on the right triangle PEB, and also we focused on the right triangle CMB, and if we focus on the right triangle EPB, we can say that sinus beta equals to PE over PB, and if we focus on the right triangle CMB, we can say that sinus beta equals to CM over CB. So in total we got that sinus beta equals to PE over PB, that equals to CM over CB. And we made our second equation from this equality, PE over PB equals to CM over CB. But again, we know that PE equals to R, is the radius of the circle. And PB equals to 90 minus X, because PB equals to AB, that is 90 units, over AB, that is 90 units, minus AP, that is X. So in total PB equals to 90 minus X. Okay? So we know that PE equals to R, PB equals to 90 minus X, and CB equals to 50 units. It is given us in the question. So we can put the data in the second equation. We will get that R over 90 minus 6 equals to CM over 50. And we got from the second equation that R over CM equals to 90 minus 6 over 50. Okay, but we already know that from the first equation that R over CM equals to X over 70. So we have equation 2 that states that R over CM equals to 90 minus 6 over 50. And we have also from equation 1, we know that R over CM equals to X over 70. So we can create the third equation that states that R over CM equals to R over CM. And then we can put in this equation the value of R over CM from the second equation. We will put it here for this R over CM, and the value of R over CM from the first equation we will put in this side of the equation. That is to say, we put x over 70 in this side of the equation, and we put in this side of the equation r over cm, the value of r over cm from the second equation, that is to say 90 minus 6 equals 90 minus 6 over 50. That is r over cm from the second equation. And here we put r over cm, the value of r over cm from the first equation. So we got that 90 minus 6 over 50 equals to x over 70. And then it is very simple equation. One variable that is x with one equation only. So we got at the end that from the first equation that 2x equals to 105 units, but we defined, according to our definition, AP equals to x. So we can write the fourth equation that AP equals to x. If AP equals to x, so 2 times AP equals to 2x. Okay, so here we created the fifth equation, that from the third equation we can write that 2 times x equals to 105. But from the fourth equation we know that 2 times x also equals to 2 times AP. So we can add here that 2 times x equals to 2 times AP. So at the end we have this equality that 2 times AP equals to 105 units. And this is actually the final answer to the question, that 2 times AP equals to 105 units. So the value of 2 times AP equals to 105 units, or the size of 2 times AP equals to 105 units. Okay, thank you very much.